Similar case, people are using the land use and urban firms and accessibility. The initial is the urban lands use as per capita. Per capita, what should be the land uses? Land use by class wise and the zone wise. We can divide into the different class and the different zones based upon that find obtain the land uses. The employment density by urban size, class zone. Like if you see the few areas, like they are heavy heavy employment because where the ecosystem ecospace area is there. There is like there is like tech parks are there. When you have a tech parks, these type of things are there. Hello. Then the third division is that when the third short-term uses is that working to work and the ratio of the job to employed labor force, where that uh, basically the ecospace and area there the employees are much more and different to support that there are different jobs are available that okay, this is for food chain is there, then transportation chain is another things. So oh, these are the short term addition we can tell. So the long term is that population, urban population and the employment served by the transit, the share of population and employment growth uh, already on urbanized land, travel and modal share by urban zones. So there are different things are there. The supply, transportation, infrastructure service, the length of the paved roads. They measure the index of energy intensity cars and trucks for the technology-based method, and the index for that emission intensity of the road fleets. Then, similarly, for the short term, percentage of alternative fuel vehicles, percentage of net government transportation expenditure spends on the ground ground-based public transportation. So these are the different methods for the short-term plans as well as the long-term plans. Uh, from environment, social, economic, sustainable to emission. So when you go for that sustainable urban transportation, so that moves from that emission and the air quality, then mobility, then equity. So the sustainability problems has a different category. We that lead to the emission and air quality, where you can have much more focus on it. Emission, the pollution, emission, air quality. You check the air quality index. Based upon that, you suggest the different things. Nowadays, Diwali is coming, so that you will heard about some air quality.
Sir, sorry for the disturbance, sir. Slides are not visible, sir.
Now the slides are not visible.
Yes, sir. Just now stopped, sir.
Is it visible now?
Yes,
Yes,
sir.
sir, it is visible now.
Thanks. Thanks, sir. Uh, so how will you control that emission by putting rules? One of the things is by putting rules to improve the air quality, and that frequently you check the pollution in a vehicles, different vehicles, and provide the fines, and based upon that you make a rules on it. So based upon that each and every area you have a scope for improvement. So uh, apart from that, so in the visualization mode, just there is a wide scope for walking, make travel mode large. People should go for work. If it is a short distance, whatever, people should go much more the walking base than the cycling, that is reduced. Less people go for that public transportation, less than that cycling, less than that heavy vehicle, cars, personalization, the personal cars, those should be monitored under control. If you reduce number of the cars and all, that will improve also the traffic. But every each and everything will going on. The prompting by cycling traffic. You can have cycling traffic like these are the cycle way, these are the area where you need to have a cycle. So these are the place you will go for the cycling. So the prompting by cycling, you can ask for uh, develop first you need to develop a cycle infrastructure. After that uh, after that you need to have the prompting by the cycling. Then make the public transportation more efficient. So these are the public transportation you need to the make more efficient is like much more available and frequently. If you provide like this architecture, like it's a kind of the double tracker and a single tracker, a double mode there, so that will be more efficiently developed on it. Then equitable allocation of the road space, like you can see. So how will you see that in this area there is only the cars, few cars are there, then you will what you will have, you divide this. Okay, you have a cars, and after that you need to have uh, space for cycling, you need to space for walking as well. That is what the equitable space allocation. Not only for the cars, we should have the cycling and all. That will reduce the traffic calming. The traffic calming planning is like you have a trail entrance for this. You need to have a shortcut entrance. Then you have a median, short median, the speed humps, mark crosswalk, and the speed humps. Like that will be reduce the traffic on it. The road pricing. See, if you provide increase the road pricing, the number of the cars will go on decreasing. So that is what uh, reduce the pollution and then if you don't have such type of facility, you can see the cycling person is going on. There is if he or she may face the accident on it. How to reduce the lack of budget for funding urban mobility, limited skill staff resource. If you don't provide this. Uh, so the no clear cut like limited skill for that, no clear cut responsible, lack of stakeholders involvement. These are the different things. If you don't have proper planning on it. So now I'm going for what are the different techniques we used to develop. So our area, we are not dealing with all these things. We are just focusing on the few parts of that. There is a huge. This area is this domain is very huge. The complete things we can work entirely, but here we are just limiting the few areas. These are the places where our involvement is there. Stage is the where the our involvement is there, and we are developing through our recent technique, the GPT-based method, not only developing the strategic and planning everything. We will ask GPT and it is helpful to that. First, we are detecting, we are generating, then we are suggesting all kind of facility through this GPT assistant training pipeline, like the stage-based method, the pre-training, self-supervised training, reward modeling, and uh, reinforcement learning. So when you have like large company like Microsoft, Google, Nvidia, Facebook, they are doing the pre-training on a huge amount of the data. You can see there is thousands of GPU, months of training like GPT, Llama, and that. So we can't spend for an individual or for the startup, we can't spend such a huge cost. To do that, what we can do, we can use 1 to 100 GPUs, few days of training, like Vakuna 13 billion parameter. So you can build on this and do the self-supervised thing. The reward modeling base, that is also the 1 to 100 GPU from few days of training. Similarly, for the Chat GPT, GPT is a core model where the Chat GPT is a reinforcement method. Claude, Chat GPT, they can use that. A backbone is GPT, and based after that they are putting the reinforcement learning. You can have a prompt of size prompt 1K to the 100K prompts written by that different contractor, low quality or both high quality. Then you will use a reinforcement learning to develop that. So to do that, it required a lot of money. So that's I'm giving that basic of that. One part is that detecting uh, where is the traffic problems are there, and how dense is the problem. We are approaching the one classification based method and the regression based method as well, also density estimation based method. To do that, we are using the machine learning course, the machine learning methods, that is supervised learning, that is classification. When you have apples, you will call this is a apples. When you have a banana, during the inference time, we will provide just a this we train with these apples and inference. We ask for what is this. We train with these apples inference when you show this and ask what is this, the banana. That is what the supervised learning. Unsupervised learning, we don't have any levels. Just we need to the cluster it based upon the same color and structure. So it will do the clustering and do it. So how to do the supervised learning? It will learn from the past input and make the future prediction as an output. The regression and the classification one. So it's a regression is like the temperature is what would be the temperature going on tomorrow? Will it be the cold or the hot tomorrow? Like that is the temperature based model number. So the classifier, like the linear method, decision tree, support vector machine, neural network, kernel estimation methods, then the Bayes method, the logistic regression, perceptron method. Just I will give one example, like why SPM is widely used in this week. Let's say last week my son and I visited the fruit shop, and he found that fruits which is similar to both apple and strawberry, and he asked that what is that is that apple is that an apple or a strawberry? As a parent, we are giving the supervision that this is a strawberry because the shape is more close to that. It is strawberry. So, so different way of putting barriers on it and discussing okay whether it is a strawberry and that. Then another method is known as the support vector where you have a level data, then you will provide a line where it will differentiate strawberry class and with the apple class. This is known as the basis and bound. When the new two classes are there, if it is belongs to this area, then you will call as a strawberry. If it is belongs to this area, you will call as a apple. This is what support vector-based methods are there. This theoretical concept is the max margin and the min margin problem. We will have a negative hyperplane and the support vectors. These are the support vectors which decide these planes, the positive hyperplanes and the max margin hyperplanes and the negative hyperplanes. The goal is to make our large margin as much as possible so that it can easily classify between the two different classes. So we have a linearly separable. Then the problem comes when you don't have a linearly separable. This is a linear separable. When the some data are there, you will have a like that. So you don't have a linear separable. Then you need to have a higher order. Instead of the linear, you will go for that curves and higher order things that is known as the kernel based method. The kernel-based method useful for that non-linear separable. Here you can separate linearly, but here you can't separate linearly. That is the kernel-based method is required. The non-linear separable that you will convert from one dimension data to the two dimension data. So here in a one dimension you can't separate the blue lines with the yellow lines, blue dots with from the yellow dots. So what you have to do, you have to plot it to the two dimensional so that now we got the results like in a two dimension, one dimensional it is. When you have a two dimensional, you will have all the yellow lines is coming there. You can plot a line there. When you plot a line there, then you can easily put a line there so that all the yellow lines are coming that all the blue lines are coming that. So this is what when you can't able to put a line here because two blue lines are there. Now you have to band it to the two dimensional. What is that two dimensional? Y equal to x square is just known as a parabola. You will fit to the parabola. So the parabola will you will fit these dots to the parabola so that you will have a linear easily separable with a line without any dots. Similarly, when you don't have a solution for a two dimension, you can go for that higher order dimension that like you can go for the higher order dimension like three dimensional and the multi dimension. That is what the future space is there. Then another use case is like you went to the zoo and well that is that is that a group of crocodiles and the alligator. So it is very now you need to have a fine grain information that okay you need to have a this or you need to have that. How will you do that? Uh, it's a, both are looking like similar. Then how will you differentiate and distinguish that? So you need to find out different feature for that. So the first feature is the crocodiles are in large size, where the alligators are the small size. Crocodile has a narrow snouts and alligator has a wide snouts. So these are the wide snouts. They are elevator, and if it is have these things, they have a crocodile on it. So this is based upon that size and shape of the snouts. You find it out whether it is a crocodile or whether it is an alligator. Like that, different kinds based upon the task you have to divide it. Uh, support how will do the support vector, and how does this support vector helps to do it. So the simple use cases is like face detection, text hypertext uh, categorization, text and hypertext categorization, classification of image, bioinformatics. Like in a traffic, you will find different faces, and based upon the face, you will count number of the persons present, or number of the heads are present. So then you need to find number of the distinguishable image, so that you can easily count it. After that, you need to have something like a text classification or text categorization. You will find out for a different category, you need to provide a different kind of text. For car, you need to have a different text. For bike, you need to have a different kind of text, so that the speaker will utter it as according, the RJ will utter it as according. To generate that, the people are using one of the famous method is known as the Simba. Simba is a state space based model, and it uses Simba is a state space model. It uses uh, Mamba-based architecture for the sequence learning, and MLP for that channel for sequence mixing. Mamba, Hyena, S4, attention are there. In Simba, we use the Mamba for the sequence mixing, and the ineffective for the efficient uh, Einstein fast Fourier transform is known as the ineffective. So that it is an efficient channel mixing technique where we are using for this is for the generative model. They are very good at generative as well as that they have a good quality for the classification as well. So so apart from that, it's similar to the transformer architecture. We have a layer now. Then instead of self-attention, we are using Mamba, then dropout, then residual connection. Similarly, layer now, instead of the MLP, we are having the dropout. Whether transformer, here we are having a self-attention, here we are having a MLP. So inside that, you can see that it's a linear projection, then state space model, then you can generate that. So ineffective is a Einstein matrix multiplication method in the fast Fourier transform. That is a spectral domain. X is transferred to the spectral domain. Then you will do the frequency mixing using the ineffective. Again, you will do the another layer of ineffective mixing. Then we have something as the inverse fast Fourier transform to bring back to spectral domain to the spatial domain. First FFT from spatial to spectral, then Einstein matrix multiplication, again one layer of Einstein matrix multiplication, again IFFT for spectral to spectral to means first FFT, then uh, the Einstein matrix multiplication, again from Einstein matrix multiplication, again one layer of Einstein multiplication, then it goes for Fourier transform. So you can see there is another work. Mamba is also a famous work. You can use that. I think I can share this paper so that you can refer this paper Simba. After that, when you have a multiple classification model, let's say we have a for a different area, we integrate different classifier model. After that, we integrate those classification model, and we'll have a parallel mechanism to combine it and give that. Another we are using a boosting method is a sequential mechanism. One is passed to the other, passed to the other, like that we are doing that sequentially. Then the bagging, it's use a simple average kind of things. It's output of all these things is based upon the average. The boosting is the weighted average, whatever this weight is given by the E1 to the E2, E2 is given by the E3, like that the weights are there. So these are the things for today. If you have any questions, please let me know. Hello. Do you have any questions? Hello. Hello, is it audible?
Yes, sir, it is audible. Till now, we don't have any questions, sir.
Okay. So
Yes,
this
sir,
is
it is
what I
audible.
have for
Sir,
But you have said some link, no, sir. It's about a
you.
PDF paper, sir.
Yeah, it's a Simba paper.
Yeah, we were just referring that, sir. That's why we could not answer your question.
Yeah, there is something like Dheeraj is. Can you ask the question like SVM has some great work? Can you use neural? Absolutely. That right now people are using the neural network based methods, like basically a transformer based method to do that. Uh, uh, the how efficient is SVM? How efficient is neural network fluency based? The Simba paper also we have evaluated transformer based method, the advanced transformer, that is state space based model based method. Is it clear, Dheeraj? Definitely you can use neural network. Transformer, SSM, all are and neural network based. Thank you. Any other questions? Thank you. Okay. Thanks all. Thank you.
sir, no queries, sir. Uh, sir, thank you. Thanks for your valuable insights, sir.
Thank you. Thanks a lot. Okay. Thank you. Bye bye. Okay. Bye. Today, this is what I have. So biggest challenge, whatever the Asia we are facing is first is the transportation, second is the pollution, and in the first slide I have shown the different kinds of problems we are facing on it.
Thank you, sir. Thank you very much, sir. Thank you.
So like traffic is first problem, the second is the air pollution, third is that efficient public transportation. These are the challenges we are facing for, uh, these are the biggest challenges for the face. Thank you. Thanks, Lord. Okay, if you have any other question, do you have any other question? Okay, then bye. Bye. This is what I have for today. Bye bye.
నాకు పెట్టేదాన్ని వెళ్ళి క్లియర్ పెట్టాను.
So, hello everyone.
Yeah, good evening.
Yeah, good evening, sir.
ఒక్కొక్కసారి ఫోన్ టచ్ చేసామంటే
Shreya, you can start now.
Yes, sir. So, good evening, everybody, and welcome back to the of this of this seminar. And today we are pleased to welcome Dr. TVS Vivek, who has already delivered an insightful session on electric and shared mobility, infrastructure, and adoption strategies. And today he will be speaking on the topic digital twins and simulation tools for urban mobility analysis. We are delighted to have him with us once again, and we are looking forward to another informative and engaging session. Thank you.
So, Vivek sir, over to you, sir. Vivek sir, Vivek sir, over to you. Vivek sir, are you there? Hello, Vivek sir. Hello, Vivek sir. Vivek sir, are you there? Sir, over to you, sir. Over to you. Please start the session, sir.
Yes, sir, can you hear me?
Yes, sir. Now it is audible, sir.
Yeah, thank you for confirming, sir.
Yes, sir.
Yes, thank you, everyone. So today's session is based on digital twins and simulation tools for urban mobility analysis. So I'm going to speak about what is digital twins, its architecture, followed with how to build the urban digital twin. I mean the different steps that are involved here, and what are the different components of digital twin and different simulation tools, followed with the workflow of digital twins and how to integrate this digital twins with different types of simulations, followed with the different case studies, and we'll see what are the different challenges that are going to be existed in digital twins. And finally, we'll wind up the session by going through the future directions, followed with the roadmap. So how can we define this concept of digital twin? See, digital twin can be defined as a virtual representation of any physical system. Like you can call it as a virtual replica of any physical system. Like for example, if you are going to include a physical city, it mainly concentrates on the buildings that are going to be taken place in that city, the infrastructure networks, environmental conditions, where in the environmental conditions we are going to see the soil as well as the sand conditions also, and the population movements. So all these are going to be represented virtually, and this digital twin is going to use different IoT sensors, data analytics, and artificial intelligence to show the physical image digitally. That means to show the opposite image digitally. Usually, the concept of digital twin has been originated for the departments like manufacturing and aerospace. So previously we used to use this in manufacturing and aerospace. Now it is widely used in urban systems. So this concept, digital twin enables what if analysis as far as the virtual replica is concerned. It is mainly going to concentrate on what if analysis, where it concentrates on predictive maintenance and continuous optimization. So the architecture of digital twin mainly contains 5 layers. The first layer, which is physical layer, it concentrates on real world sensors, the GPS trackers, different types of vehicles and its infrastructures. So this physical layer is going to become the first layer in this architecture of digital twins. And the second layer is a data layer, which concentrates on real-time data aggregation, followed with the videos, audios, and it is also going to consider the environmental data also. So the aggregation and storage, it concentrates on the aggregation as well as the storage of all these components. Whereas the third layer, the model layer, mainly concentrates on the simulation and AI models, which are representing the whole city network. So analytics layer, it will give you the output in the form of visualizations, more specifically in the form of dashboards, as well as it is also going to speak about the algorithms that are used to analyze the performance and predict the scenarios, which mainly comes under this optimization. So analytics layer is very, very important, as different types of dashboards are created for each and every phase of a project. And the last layer concentrates on the feedback loop, where in this feedback loop, the engineers are going to generate the real-time updates. So there will be a continuous data update, and this model is going to influence the real-world decisions. So the architecture of digital twins mainly concentrates on these five steps. So starting from the physical layer to the feedback layer. Now, so this slide mainly concentrates on how to build the urban digital twin. So to build an urban, there are 3 main considerations which are to be taken into the account. Like the first one is the data sources, second one is connectivity, third one is platforms, and these 3 are going to become the heart of building the urban digital twin. Followed with, we have 2 more steps like modeling and simulation engines and visualization interface. Now, this data sources mainly concentrates on different types of data, like the data that is collected from IoT sensors. So IoT sensors are going to get a data from air quality, the noise levels, temperature, humidity, traffic flow, as well as the parking occupancy. So IoT sensors are going to concentrate on all these steps. And you have another type of data as a geospatial data, which purely concentrates on high resolutions of 3D models, maps, and it also focuses on satellite images. And another category of these data sources is historical data, which mainly concentrates on the different traffic patterns, weather events, energy consumption. Now, all these categories comes under these data sources. Now, if you take the connectivity into consideration, so this connectivity mainly concentrates on how all these devices are going to be connected without any sort of problems. And modeling and simulation engines mainly focuses on the different simulation tools that are required in this urban digital twin strategy. And the visualization interface is going to give you the overall architecture. Okay, that is depends upon the requirements engineer. So depending upon the requirements engineer, okay, the visualization is going to give you the interface in the form of virtual replica digitally. And it also focuses not only on the overall diagrammatic format, but also on the different types of dashboards. So for each and every level, or for each and every level that is going to be existed in these digital twins, a dashboard is going to be created. And once from the dashboard itself, you can come to know what are the different advantages and pitfalls, or do we need to do any sort of changes like. So most probably, building the urban digital twin mainly concentrates on the data sources, connectivity, and its different platforms. Now, there are different components that are going to be existed in this digital twin. So the first component we are going to concentrate here is about the data acquisition modules, where we collect the data from the traffic lights, the GPS, mobile apps, etc. And the simulation engines, they are going to run different simulation models like Sumo, PTV Vision, etc. Artificial intelligence and machine learning models are going to predict the congestion, travel time, or emission patterns. So by integrating this urban mobility digital twin using GIS, I mean the graphical interface systems, the maps, the spatial data can also be viewed very particularly. And the decision support dashboards mainly gives us the visualization tools for city planners and transport managers. So each and every component is going to help the city planners to complete the task successfully. And each and every component is going to be existed in different levels, in the different architecture levels. Like if you see here, there are different simulation tools. So the first tool and very well-known tool here is Sumo. So this Sumo is going to model each individual vehicle explicitly. It is also going to concentrate on what is the route of that vehicle, what is the position of that vehicle, the speed of that vehicle, as well as the behavior of that vehicle. And this Sumo comes under the open source tool. So there is one big speciality with this Sumo tool. This Sumo is going to provide the traffic control interface. It is a very best and very good application, okay, where it is going to control the traffic by using this Sumo. And there is one more bigger advantage of this Sumo is that it is going to read, or it is going to consider the XML based formats also. Extensible markup language formats are also being taken into consideration. So the tool Sumo is widely used in both academia as well as industry. So as far as the industry is concerned, it is used to test the new control algorithms, study the different routes, evaluate the emissions, and experiment with autonomous or automated driving behaviors. All these conditions are going to be satisfied with this Sumo simulation tool. So everyone can download this tool as it is available in the open source format. The second simulation tool here is MATSIM. So the full form of MAT is multi-agent transport simulation. And this MATSIM contains different agents. These agents not only decide the route, but they also decide the departure times of the vehicle, the modes of the vehicle, like whether it is a bicycle, car, or bike, like that. So this multi-agent transport simulation works on iterative loops. So as the agents are going to deal with the routes, the departure times, followed with the modes, the iterative loops are going to be taken into this. So this MATSIM is widely used in research and planning. Like Sumo is widely used in academia and industry. So like here, the MATSIM is widely used in research and planning for evaluating the infrastructure investments, transport policies, new mobility services, as well as active transport. So there are many more components here. I'm just adding up with some components like the transport policies, infrastructure investments, new mobility services, and active transport. So as far as these digital twins are concerned, the Sumo tool and MATSIM are going to play the most important role. Whereas we have some other simulation tools like AIMSUN. So AIMSUN usually it is going to concentrate on real-time traffic management systems. There is one small disadvantage with this AIMSUN is that it only concentrates on the traffic management, but it will not concentrate on the other digital twins. And we have one more simulation tool like AnyLogic, and this AnyLogic comes under the category of multi-method simulation platform. So where by using this AnyLogic, you can able to compare and contrast the different simulation tools by seeing their outputs. Like the output is going to be shown in the form of efficiency, the output which is going to be shown in the form of throughput. So all these can be easily compared. So that's why we call this AnyLogic tool as a multi-method simulation platform, where the user can able to see and take the decisions as far as this digital twins are concerned. See, these are some tools which I have which I am showing you here, but there are many more tools of simulation. Like we have PTV Vism. Okay, so this so that PTV Vism mainly concentrates only on licensing aspects. And there are small, very small projects, okay, on these simulation tools also. Like you can take up a small scale you can take up a small scale project, and you can try to test it on these type of tools using Sumo, Maxim, or any logic. Now, let us concentrate on the workflow of these digital twins, like the workflow from data to simulation. So if you see here, the workflow in this workflow, the first step is about the data collection. So data is going to be collected from sensors, cameras, GPS, mobile apps, and also by using IoT. The second step,
phone తీసుకొచ్చా మళ్ళీ వచ్చింది కదా ఒక 10 నిమిషాలు ఆగొచ్చు కదా
and the second step mainly concentrates on data cleaning and data pre-processing, where you are going to clean, filter, and normalize the data to remove the noise. The third step, the third workflow concentrates on model building, where you are going to construct a virtual model of cities road network, for example, cities road network. So the fourth workflow also concentrates on calibration and validation, where you are going to adjust the parameters for the simulated outputs to match the real world data. So scenario testing, the another workflow, mainly concentrates on signal optimization and the visualization. So the last workflow, like the feedback, it is going to give the findings in physical world and monitor the whole results. So the workflow starts from the data collection and ends with the feedback. So it is not like that there are only 5 steps of workflow here. Like these workflow steps can also be extended to 7 or 8, or can also be compressed to 3 to 4. But it all depends upon the project that we are going to achieve. And by following these workflow steps, you are going to ensure that accuracy and adaptability are easily achieved here, because in each and every step you are going to do from data collection to feedback. Now let us see how to integrate the digital twins with the different simulation tools that we have seen in the previous slides. So digital twins nowadays became more powerful when they are going to be linked to the real-time simulation tools. So the data is continuously given to the twin, okay, where the live monitoring and predictions are done. Examples, so we have some couple of examples, like the adaptive traffic lights, which are controlled by the simulation outputs. And a second good example is predicting the congestion for every 15 to 30 minutes. So the key benefit for authorities is that it is going to give the real-time decision support. So by integrating these digital twins with simulation tools, the real-time decision support, as well as it also enables the closed loop optimization, where a continuous cycle is running from sensing, simulation, and improving, and again it comes back to sensing, simulation, and improving until it reaches to the certain level. So that's why we usually call this integration that it supports the authorities, okay, especially while taking the decisions in the real time. So if you see some case studies followed with applications, so there is one case study named as Virtual Singapore, okay, where it is going to be scaled for 3D digital twin, which are mainly used for urban planning, emergency management, and traffic simulation. So even the ambulance management is also going to be taken as a part of this. And second case study, which concentrates on Helsinki digital twin, where it combines the energy, mobility, as well as the environment data for sustainability studies. So there is one more case study using Siemens city performance tool, which mainly analyzes the environmental impacts of transport policies for different countries. So all these three projects demonstrates how the data driven insights are going to improve the city more livable and reduce the emissions. The ultimate goal is to improve the city livability as well as to reduce the emissions. So all these three case studies focuses on that area also. Now, if you see the different research trends in these urban mobility twins, okay, artificial intelligence and machine learning are mainly used for demand prediction, travel time estimation, and route optimization. Whereas the reinforcement learning concentrates only on automating the adaptive signal control systems. So these multi-agent systems mainly represents different entities like the drivers, the pedestrians who are walking on the road, and buses as independent decision makers. So there is one important research trend in integrating with 5G followed with edge computing. So upon integrating with 5G and edge computing, we are going to enable faster communication between the sensors and simulation servers. So the ultimate goal of this research mainly focuses on scalability, interoperability, and sustainability. All these three has to be achieved. So in AIML, the travel time estimation and route optimization are going to give you the real-time analytics. And integrating this with 5G and edge computing is totally the upcoming area, and I mean the upcoming project in this. Now, there are some standards that are going to be existed in this digital twins. Like we have one architecture named as Fireware architecture, which is an open source platform which provides the standard APIs for smart city integration. And the second standard is ISO 23247, which mainly defines the frameworks for implementing the digital twins in the departments of both manufacturing and cities. So there are open data standards, which encourages the sharing between the urban mobility systems and simulation tools. So with these standards, we can come to a conclusion that the software and hardware components are going to communicate effectively to complete the task of these urban digital twins. So each and every standard that is specified in this slide is having its own functionality. Like purely to say, this ISO 23247 existed previously in the departments of manufacturing as well as aerospace. Now it defines the frameworks for cities also. Now let us see what are the different challenges and limitations that are going to be existed here. So the like one of the challenges is data privacy. We're collecting the citizens' mobility data, which raises the ethical and security issues. And we have another challenge as computational cost, where the large scale simulations demand powerful hardware and the cost is too high. So there should be a model calibration which is going to achieve accurate models in the aspect of time consuming and data intensive. So scalability, which is very primary challenge, as we are moving from local to citywide models. This scalability requires some sort of standardization. So each and every challenge is going to give us some sort of projects, especially in the area of digital twins. So there are many funding groups which are going to accept the proposals on these challenges and limitations, purely on the challenges and limitations of digital twins. Because data quality, which is a very big challenge, security, data privacy, and even this digital twins can also be integrated as one of a challenge using the blockchains. So let us see what are the different future directions that are existed here. So edge computing as one of the future direction. Using this edge computing, you can able to reduce the latency for real-time responses. The quantum computing, where you can able to optimize the complex real-time routing, as well as you can able to schedule the problems very faster using this quantum computing. So metaverse integration, which focuses on a very depth visualization of city models, especially for policy testing. So the visualizations that are going to be considered in this metaverse based is not like 2D visualizations. So those visualizations are like in the form of 3D only. So there is one more important future direction where you are going to integrate the blockchain. So by integrating this blockchain, you can ensure secure as well as tamper-proof data sharing. So there is one more challenging future direction is digital twin as a service. In short, you can call it as DTAAS. which is an emerging concept for cloud-based urban simulation services. So if you carefully observe these future directions, much more stress is on interdisciplinary collaborations. See, education is one area. Simulations comes under the different areas where you are going to, okay, where you are going to combine this edge computing with simulations, which is an interdisciplinary collaboration. So these are some of the important future directions that are mostly existed in these digital twins. Yes, is my voice audible?
Yes.
Okay, ma'am. Thank you for confirming. Now let us see about the implementation roadmap of these digital twins. So the first step mainly concentrates on defining the objectives, where our concentration is mostly on improving the travel times, generate lower emissions, and reduce the congestion. So as far as this objectives identification is concerned, these three are the important parameters. And the second step is about the data collection, where you are going to install different IoT sensors and integrate with the existing data sources. And these data sources are purely the real-time data sources. And the third step is about model development, where you are going to develop and build the simulation models using the simulation tools like Sumo or Maxim, as we have seen in the previous slides. So either you can take the Sumo tool or Maxim tool for model development. And the next step concentrates on integration, where you are going to combine the real-time data with predictive analytics. And in this integration, you are also going to design the different dashboards. So to define these dashboards, the best tool is using Tableau. And the next step mainly concentrates on the validation, where it purely focuses on field observations. Like it concentrates on the outputs of each and every phase of the project. Like even though if there is a small sort of input, so what is the output that is going to be gathered when the input is given. So for each and every output, the validation is going to be cross-checked and it is going to be recorded and observed. So the last step mainly concentrates on the pilot testing as well as scaling. So this is very, very important, as we need to start our journey by taking the small project into consideration, refine the project, refine the requirements of the project, check whether the requirements are satisfied by the client or not. And once, if the client is satisfied with these requirements, then you can able to expand this to the city level deployment also. So what I'm trying to tell you here is that start small, refine it, and then expand it to the city level deployment, rather than going for the big one and getting confused. Okay, it's better to start with a small scale projects. Like this is the roadmap implementation of this urban mobility digital twins. Now let us see some of the research opportunities that are going to be existed here. So nowadays there is a lot of exploration in artificial intelligence simulation frameworks, especially for the nation development. And the second step focuses on integration of machine learning with IoT data fusion for generating the real-time traffic management. So the third research opportunity mainly focuses on taking the satellite images into consideration for mobility modeling. And you can also able to collaborate with different municipal corporations or smart city missions where you are going to achieve public-private collaboration models. So a lot of research is going to be taken in this area, especially when you take this satellite images into consideration. A lot of work is going on. So let us see the summary of this presentation, where the digital twins on combination with simulation tools, you can able to complete the work smarter, safer, and you can able to design sustainable cities. The integration of IoT with AI and simulation leads to data-driven policy decisions. And the future mobility systems are going to depend on the real-time adaptability of these digital twins. So there is a lot of emphasis on the urban mobility analysis as far as the departments like civil engineering, computer science, and urban design are going to play the most important role, especially the civil engineering and urban design, which are very, very important in to accomplish the task of these digital twins. And the computer science requires the knowledge on different simulation tools. And if you carefully see here, there is a lot of collaboration between different domains. So we require a civil engineer, we require a urban design engineer, we require a computer science engineer, where the computer science engineer focuses on the tools, simulations, softwares, on all these categories, and the civil engineer focuses on the environmental aspects. Even soil, sand are also taken into consideration. So the architecture students mainly concentrates on this urban design. So please let me know if you have any sort of queries. I'll answer. Yes, if you have any queries, you can ask me.
Sir, good evening, sir.
Good evening, sir.
Hello.
Yes, sir.
Yes, sir. So very good presentation, sir.
Okay.
Sir,
Thank you, sir.
what kind of tools we can use for the driver behavior, sir?
So driver behavior, especially in which aspect you are concentrating, sir? Let me know that aspect.
Like distracted driving. So driver generally behaving different distractions while driving. He induce like mobile phone usage, all these things.
Okay.
So how can we, I mean, get this road safety aspects from this? By any AI
So,
tools we can apply.
uh, like uh, like we have one simulation tool like MatSim, which I specified, which mainly focuses on agents. These agents are also keeps a track on that vehicle. Okay, and they also concentrates on the behavioral aspects of the driver. Like sometimes what happens is while driving, the driver may go into a small sort of sleep sensation. So whenever
Okay.
the type of cases comes, by using this maxim nasal, the agents can able to clearly get that information, and they will try to caution the driver as well as the passen- co-passengers also.
Okay. So it's a simulation how it is caution, sir. So how we can alert the driver?
These agents who are categorized into different parts, so they are going to either caution the driver like by giving a call or by giving a message, or they even caution the passengers also to call the driver as he's in different mood of sensation. So this tool will try to integrate by taking the GPS cameras into consideration, and the agents will be quite observing. like uh, like if you take the one more tool like any logic, and if you try to implement the same case study in that any logic, so as I told you that this any logic concentrates on multiple simulation tools, like you can able to verify which one is having the highest consistency or which one gives the highest consistency in this particular aspect. So upon doing a lot of experimentation, okay, so maxim is going to give you the appropriate results in this type of cases, sir.
Okay, sir. Thank you.
Thank you, sir.
Yes, sir. Sir, this simulation based on AI tool only, sir.
Yes, sir. Both AI
Matsim.
is also integrated into it. Yes, sir. AI is also integrated into it, and to implement this maxim very particularly, even even we should know the knowledge like what is the GUI of this maxim and the different options, because these are purely drag and drop. So easily you can able to work.
Okay, sir. Okay. Thank you, sir.
Thank you, sir. Yes, if you have any other questions, you can ask me.
Sir, I have a question, sir.
Yes, sir. Please, sir. Yes, please, sir.
You have mentioned four methods wherein which we can apply all these algorithms and all. Out of them, you
Yes, sir.
mentioned about blockchain. So
Yes, sir.
we heard about blockchain-based models and all 2 years
Yeah.
back.
Okay.
So are they
Okay.
outdated right now, or is the digital twins are taking their place? What
Uh,
is their role nowadays, sir? Blockchain technologies.
Sir, usually, sir, frankly to say, nothing is outdated or nothing is old or nothing is new. But what we need to take the consideration here is that by using this blockchain, how you are going to overcome the data tamper. Okay,
Is
and
there any
what are the different?
successful launch of blockchain-based models in any of our governments or any of the seat of power in India or any other place?
Like if you take our country India into consideration, they have adopted this blockchain in this urban digital twins, but the but this blockchain purely concentrates only on the aspects like uh, okay, how to overcome the different tamper proof methods, because as the technology gets increased, or the hackers are also using their own intelligence. And this blockchain mainly concentrates on decentralized formats. Like it is not like centralized, it is purely a decentralized format. And that too, the data is not shared with one participant. So how many participants are there in a network? The data is shared among all those participants, but not all the full data is shared, sir. So
Is
as
it
it
like
purely
giving e-approval to kind of a e-cabinet kind of a thing is being implemented earlier? Can we think that?
sir, like this e-cabinet or e-voting are going to come into existence, sir, in the next coming days. But the main aspect which concentrates on this blockchain is that as it comes under the decentralized mechanism, sir, so each and every participant will be having their own ledger, and the message is transmitted to each and every participant. That means not a single participant will have the whole message. So without taking any sort of centralized server or centralized authority, okay, you can able to concentrate on this tamper proof mechanism, data tamper proof mechanism.
Okay, sir, got it. Thank you so much. Thank you.
Yeah, thank you. Yes, if you have any other questions, please let me know.
So this was a wonderful session. Thank you so much, sir, for joining us and for imparting all this knowledge. I am sure that this is going to be useful, especially in the fields of AI and ML. So thank you so much. And
Thank you.
we are going to conclude this session here today. Everyone can leave the meeting and we will get back together at 6 p.m. tomorrow. Thank you.
Okay, ma'am. Thank you.
Thank you, ma'am.